Oh, nothing good, nothing bad about some 80s music there, people. All right. Distinguished measures of center, or measures of variation. Okay. So what we're focusing here is deviation. And deviation simply is how far a data point is from the mean. How far from the mean of data. Data values to the left have a negative, which makes sense, kind of like a zero there. If you're to the left of the zero, you're negative. And data values to the right will have a positive deviation. So let's see what we got here. We want to draw not a line plot, we want to call this a dot plot. All right, draw a dot plot using the following numbers. So they're all pretty much bunched together, so I can do a 9, a 10, an 11, a 12, and a 13. So how many 9s do I have? I got one of them. I'll put a dot. How many 10s? I've got one. Look, these are all in order. This is, oh, how nice is this? I got two 11s. So 1 and then 2, and then I got a 12, and then I've got a 13. Okay, so again, notice I tried to keep them all on the same line as best as I could. So let's see what we got here. We need, well, to figure out the deviation from the mean, we need to know what the mean is. So in order to do that, we need to add up all of our numbers. I got to add the 9, the 10, the 11, add them all up. So I'm going to go without calculator, people. Okay, hold on. I'm going to be brave here. I'm going to group things together like I know 9 and 11 make 20. And then 10 and 11, that's going to be 21. And then 12 and 13 make a 15. Oh, 20. Ooh, 25. So when I add them up, a 20, a 40, a 60, 61, and 66. And then how many numbers are there? A 1, 2, 3, 4, 5, 6. So I'm going to divide it by 6. And look at that, 11. The mean is 11. That's there. All right. It is a coincidence that that's the number that appears twice. All right. It's also a coincidence that it's the middle number that's there. Oh. All right. So let's see here. The mean's 11. So the deviation, how far is 9 from 11? It's 2 below it. So put down a -2. How about 10? Well, 10's 1 below it. So put down a -1. 11, well, it's right on it, so it doesn't deviate from it at all. And 12, well, it's 1 above, so we put a +1, and it's 2 above, so we put a +2. I thought it was a little bit easy as well, too. But yeah, that's it. All right. Now, the one thing you will notice with your deviation is that the sum will always equal 0. Okay, and again, it's because it's a balancing pointer. So if we look at our negatives, I've got a total of 2 plus 1, so I got 3 for my negatives. And then 1 plus 2, I got 3 for my pot. Look at this, these are opposites. Knock each other out with the 0, so the sum there would be 0 when you combine everything together. So that is something we do want to watch for. All right, so let's see here. We got Michelle asked 10 of her classmates for the number of hours they usually sleep when there is school the next day. There are the responses. So draw a dot plot. Okay, so we're going to find our smallest number. It's an 8. The largest number is an 11. So we're just going to count by ones. I got a 9, a 10, and an 11. You don't have to space it all the way out. Now, I know what you're thinking. It looks like it's a lot there. I know what you're saying there. Well, yeah, let's just get it done with. It'll be fine. Grouping is going to make your life easier. Let's check the 8s out. I got 1, I got 2, a 3, a 4 of them. So 1, 2, 3, 4. All right. How about 9s? How many 9s I've got? I just got 1, so we can put 1 dot there. How many 10s? A 1 of them. Ooh, there's 2 of them. Again, I'm trying to keep them lined up there. And 11s. All right. There's 2 of them that are there. Now, do I have all the numbers down? No. Look at, and this is why I like to underline them, because in case I miss it. Yeah, the lowest number is actually a 7. So I need to continue my line over here, 7, and get a dot with it. All right, so if I'm going to figure out the deviation from the mean, I need to know what the mean is. And this is why I read directions, because it says if 9 hours is the mean, oh my goodness, they did it for me. I don't have to add them all up and divide. I know what they are. So what we do want to notice, though, is, remember in the previous problem? Look at that. See how they're all in order from least to greatest? That's what's going to make this really nice as well. Now, when they're not in order from least to greatest like we've got here, it gets a little bit messier, so we're just going to kind of organize things. But which way we're talking about? Remember the mean. The mean was what? The mean was, 9. So if you have an 8, you are 1 below it. If you got a 10, you are 1 above it. An 8 and 8, you are 1 below, 1 below. 11, well, you are 2 above, and 2 above. How about a 9? Well, right there, no deviation at all. An 8, 1 below it, -1. A 10, 1 above it. And a 7, you are 2 below it. So what I'm going to do here is I'm going to get all my positive numbers over here. So that's a 1 that's there. All right. A 2, and a 1. So 2, 4, 5, 6. I got a total of 6 positive numbers. Over here, I'm going to get all my negatives. So I got a -1, a -1, a -1, a -1, and a -2. If I add up all my negatives, 1, 2, 3, 4, 5, 6. Oh my goodness, I get a -6. It's balanced with this. Oh my goodness. So the sum is 0. So I feel good about my answer. When your sum is not 0, just don't magically put a 0 down there, because that tells you that something is off up here. So make that adjustment, make that particular change. All right, so the mean here. So the mean. A lot of times when we hear mean, we just think about the word average, and that's true. We think of it like that. What's my average grade on a test? What was the mean? But a way of thinking about it, the mean is the point that balances the sum of the positive deviations with the sum of the negative deviations. So that's why it is considered the average. So we talked about that. Okay. This one here, oh my goodness, this is a good question here. And I know you're excited about it. You're excited about what's going on here. Anytime a teacher says a good question, all right. So let's see, we got Maria's Food Pantry, all right. Gets many donations of fresh lemons. She needs to put them in bags of 8. She's going to be able to make 10 bags using all the donated lemons. There were 8 donations. The smallest donation was a 4. The largest donation was a 15. All right, so how many lemons were donated in all? Well, let's see here. She put them in bags of 8, and she made 10 bags using all the. So if there's 10 bags, 8 in each bag, 8 times 10, yes, hello, 80. We got 80 lemons in all. What is the mean number of lemons donated? The mean, so the average. Well, here we go. If there's a total of 80 of them, all right, and there were 8 donations, all right, 80 divided by 8. So we do get the fact that there were 10. So the average donation was 10. All right, so create a dot plot that could show the 8 donations. Okay, so, all right, so we do know that someone donated 4. Okay, so I'm going to put a 4 down. And we do know that someone donated 15, so I'm going to put a 15 down. I'm going to count by ones here. I think we can get that done there. So that's a 5, a 6, a 7, an 8, a 9, a 10, an 11, a 12, a 13, and a 14. Oh, did I do that nicely, huh? Go ahead. You can clap here. You can clap at home there. All right. Thank you. All right, so let's see here. Let's see. We do know we have one donation with a 4. Okay. We do know we have one donation with a 15. And we do know that the mean is 10. Now, here's the thing. You don't want to just randomly throw things out there. Remember, since one of the donations was 4, okay, remember the mean, all right? That means the deviations is all going to be balanced. So we know the mean is 10. So if I look at it right now, I am 1, 2, 3, 4, 5 above. So right now I'm at a +5. And here I'm 1, 2, 3, 4, 5, 6 below. So in order to balance it out, right now, I need a +1. Because that would get me a 6, and that would balance it out there. So if the mean is 10, I need a +1. I know I need an 11. Now, everything else has to be balanced. Because right now I'm at 0. I got a plus. I'm at 0. So let's balance them out. So if I choose 1 below, I need to choose 1 above. And if I choose 2 below, I need to choose, 2 above. This is what's going to keep it balanced. Let me see. I got 1, 2, 3, 4, 5, 6. I got 7 of them. Wait a second, though. I'm balanced, but I've got 7. 8 donations. So I need one more donation, but I don't want to tip the scale at all. So I don't want any negatives. I don't want any positive. I want right on the 10, right where the... Looks good. It does, because now I'm all balanced here, all right? And so that's the positive. Now, again, are there more than one answer? Absolutely there is, but the key thing is you need to be balanced. Now, I am going to check to make sure I stayed balanced. I got a 4 based off of mine. I've got an 8, a 9, a 10. I've got 2 11s. I've got a 12, and I got myself a 15. So again, the mean is 10, so that's why it's going to be a 0 there. If I'm 1 below, -1. I'm 2 below, -2. I am 6 below for -6. All right. 11, I am 1 above. 11, 1 above. 12, I am 2 above. And 15, I am 5 above. So let's see here. Look at all my negatives there. 6 plus 2 plus 1. That is 9. So I've got a total of -9 altogether. For my positives, 1 plus 1 is 2. 2 plus 2 is 4. Oh my goodness. 4 plus 5 is 9. That's a positive 9. I'm balanced. I'm balanced. The sum of my deviations is 0. So again, that's the key thing when we are putting those things together. The sum of those deviations, my goodness, some of those deviations need to always equal 0. So let's see what we got here now. We're going to create a set of data, which is the following characteristics. I got a mean of 4. I got 6 pieces of data, including 1, 2, 5, and 8. Okay, so I know I've got those. So I know I've got a 1, a 2, a 3, a 4, a 5, a 6, 7, and 8. And I shouldn't say I've got those. I mean, I wanted to count up from 1 to 8 there. So I know I've got a 1. I know I've got a 2. I know I got a 5. I know I've got an 8. I know the mean is 4. So I'm going to label that. All right. Now, 6 pieces of data. So I got 1, 2, 3, 4. I need 2 more of them. I need a range to be a 7. So biggest number? Smallest number. Okay, so the range is 7 right now. So what that tells me is I can't go any higher. Can't go any lower as well because that's going to mess up my range. Also tells me the greatest deviation from the mean has to be less than or equal to 4. Well, this proves if my mean is 4, that means I can go out 4, a 1, a 2, a 3, 4. That's the most I can go out. Or a 1, a 2, a 3. I could go 1 more, but if I put a 0 there, that's going to change my range, so that's not going to work. So this has to be the smallest. That has to be the biggest. Now, let's see what else we need here. I need a mean of 4. So instead of trying to add them up and divide and seeing if it works, let's use our deviations. The 5 right now. All right, I'm going to come down here. I got a 1, a 2. All right, I got a 5 and I've got an 8. So right now the 1 is 3 below. So put your -3 there. The 2 is 2 below. The 5, that's 1 above. The 8, a 1, that's 5 above. So right now I am 6 with my positives. I am 5 with my negatives. So let's balance it out. What would I use right now to balance it out? I would need another negative. Yeah, a 3, because that would give me another negative. So I put a 3 in there. That's 1 below. That's another negative. Now I'm at 6 with my negatives there. All right. And now am I balanced? Yeah, because I've got a -6. So if we add this guy onto that, gives me my -6. And now I've got my +6. So I am balanced here. So what should I use for my last number since I'm balanced? Well, I want it to be a 0, so I need to use a 4. There we go. Let's find the sum of those deviations there. If we look at our negatives, 3, 2, and the negative 1, that's the -6. Yep, so we are balanced. Oh, well done, well done. So we do need to kind of piece them together as we go through them, because that does, there's kind of a lot that's there. Okay, so we're going to hold on to this guy here. We'll just kind of pause. We'll talk about that one in class because I think that's enough for right now. All right, unless you feel, do you think we should? Come on, you think we should? Okay, well then I guess we should. No. All right, I said we were done with it there.
Ain't nobody got time for that.